I'm gonna also upload it to YouTube so you guys are able to see it once again. Today we're covering actually a very, very, very important topic today. So today we're doing big O notation and linter. Um, okay, what is, again, last time we covered code coverage, right? What is code coverage? Could anybody remind me of what's code coverage?
Like the amount of tests or the amount of parts of your code that your tests cover,
Yeah,
like branch
exactly.
coverage and then function coverage.
Exactly. So it's a measurement tool, right? It's a measurement unit. Today we're also gonna do big O. In my definition, is also a measurement unit of how fast your code go through or how complex your code is, right? First, I'm gonna talk about linter. Linter, you know, these programmers sometimes they want to be what do you say? Do you want to be like stylish kind of thing? They want their code to be the best looking code around there. So that's linter, right? You're not gonna be tested about linter, but it's something that you wanna just have, right? Something that you wanna at least know about, right? So let's talk about linter. So what's linter? Linter is just a script that is given to you. And in that script, it's like, I would say, like 8,000 lines of code in there. It's a Python script that we have, and it's given on Canvas. It's about 8,000 line of code. And what does it do actually? So this code, when you run it, it goes through your CPP file and it tells you, hey, like you have an extra space here. Your comment should be placed down there. It just gives you stylish stuff. Like it tells you like for example, let's look at this code here, right? For example, it's gonna say, oh, you don't have a space here. What are you doing? You know, like you need space after in this here. You need why is this indented this way? Like, you know, white space should not be here. All this kind of stuff. So linter is just like again stylish kind of thing. It just tells you, hey, you're doing this not the right way. There is some sort of a style problem. Does it really affect anything? No. Does it affect your memory? No. Does it affect your anything? No. It just makes your code cleaner. And it's 8,000 lines of code because basically you have all the different rules implemented in there. Okay? Does that make sense? So after going through and fixing all the errors, this is what the code's gonna look like. And it's gonna, for example, let me show you the outputs that you will get through there. So let me show you quickly. Lecture, no. So I want you to go and try linter on your own when you have time. But for the time being, just stay with me here. So this is the Python script that is given to you. And if you went through this is like, as I told you, as you see, 100 pages. And it just, all of this is just the code, right? If you want to read in depth about it, go ahead. It's already designed. It's online. A lot of people use it to style their code, all this kind of stuff. As you can see, it's just huge. So for me, when I ran the script on the hello lint.cpp that you get, this is the output that I got. And so you run this on Linux machines, okay? So it says 7 line should be 80 long characters. So it tells you how long how long should my lines be. It tells me about spaces between code and comments, at least 2 spaces, not one, 2 spaces that should be there. Should have a space between this and the comment. So again, as you see, all these outputs are just comment outputs, right? It's like styling factors kind of thing, right? So it tells you like you're missing space before this, you're missing space around the equal sign, you're missing space or before this, stuff like that, right? So it tells you all about again styling questions. And that's why I don't want to spend a lot of time on linter. I want you to go ahead and run it. So this is what you're gonna do. You're gonna put the 2 files together and then you're gonna run this line of command. You have to run it right now? No. Don't worry about it right now. Just follow the slides and do it on your own. And if you have any questions, send me an email or put it in Piazza. I don't want to spend much time in here about this one. Okay, we're gonna focus more on Big O. So if you're talking to someone, I see people are talking around all this kind of stuff. Please focus on this part because this is the most important part. This comes in exams all the time, right? Big O notation. This is what the quiz is about today. So let's focus and actually understand what is going on. So I made this example that will hopefully clarify what big O notation is all about. So let's think about it this way. You're a teacher at a school. I don't know if I'm talking too fast. Does it tell you where to have to fix it? Yeah, it does. Sorry, that's in the chat. So let's imagine the story. You're a teacher at school and you're looking for a student, Jane. You're looking for her records, right? So you go in to the database and you have all the records stacked up, right? And then you look through the first one, it's James. You look through the second one, it's someone else. You look through the third one, it's someone else. And you keep flipping through all the records until you find Jane, right? That's basically big O notation. One thing that I want to clarify about big O is that you are always looking for not the best case, the worst case scenario. So for example, if you flipped the database book, whatever, and you found Jane, the first one, that means you got it in one trial, right? So that's O of 1. But if you flip twice, you get it O of 2, right? That's you did twice, and then you got the records you're looking for. The worst case scenario would be flipping through the entire database, right? And how many students do we have there? N students. So that's why we say O of N. Does that make sense? Okay. Any questions for me about this? Okay. So again, okay, let's add more to it. Okay, so what? Okay, I understand what it is about. What is the point of it, right? The point is to make your algorithm as tight as possible. You want your algorithm to be as fast as possible, right? That's the main point of big O notation. It's actually like an interview question. It's I have it in my graduate studies classes. Big O notation is just a big thing out there. So let's continue on the same example we were talking about. Let's say it takes you 1 millisecond to check each element in the school database, right? So it takes you 1 millisecond to check elements in the school database. So if you're trying to check 10 entries, it's gonna take you 10 nanoseconds, right? That's just a simple search, searching through the database one by one. But what if you know something else that is gonna make it even faster for you? What if we did a binary search? Binary search, you're gonna get through 10 runs in 3 seconds. But in a simple search, you're gonna have to do 10 milliseconds. So I mean, 10 seconds to 3 seconds, what's the big deal, right? It's not that big of a difference, right? It does when you're trying to do this huge number here. For a simple search, it's gonna take you 11 days. For a binary search, it's gonna take 32 milliseconds. So even less than half a second or 1 second or whatever. Right? Okay, so I want to give you a more intuition about the different searches and their big O notation. So a binary search, the one we just got introduced to, is O log of n. Simple search is O of n. Quick sort is n times log n. Selection sort is n square. Traveling salesman, don't worry about it too much. I don't think you ever gonna encounter the traveling in this class. But if you're interested, Google it. It's actually very fun to learn. Okay, properties. I don't like sitting here and actually reading out the properties to you. I would rather do them in examples if that works for everyone around. So I would rather actually go in and give you the examples and then tell you the properties through there. So if we have a function here, right, and it just prints, the function does the name, prints the first element of an array. So you're given an array and we're printing array at 0. That is just O of 1. Why? Because we're only accessing one thing of the array. We're not going anywhere, right? We're not like going through an entire database. We know where we're going. But if we're printing everything of the array in a for loop, this is going to be O of n. Because we have to iterate through the entire for loop, the entire array. What if we did a nested for loop here that will print the rows and columns? This one for loop was O of n, but this one, it's a nested. So inside this for loop, you have to iterate for each iteration of I, you have to iterate j from 0 to size. and then I increment by 1, and you have to do that again, and then I increment by 2, and then you have to do this for loop again. And that's why the O notation is O n square. Moving on. Fibonacci. Okay, I kept saying I don't want to explain Fibonacci. So Fibonacci, just if you know what's Fibonacci, you will understand. But if not, it took so long this morning to actually explain Fibonacci first and then explain the other thing. So I'm just gonna ignore it for now. It's just an example that I decided to add. But let's talk about some of the properties that we skipped over. One of the main property is dropping the constant. What does that mean? So we have this function here. It's printing all item twice. So you have a for loop that prints the items, and then you have another for loop that prints the item. So each of them we learned, this is O of n, this is O of n. So you end up with O of 2n, right? But one of the properties is that we drop the constant value here. So it ends up to be O of n at the output. We drop that constant. We don't care about it too much. That's one of the properties. You drop the constants. Because think about it this way. N is just an arbitrary number. It could be 9 million, right? If you multiplied it by 2, it's still an arbitrary number. So it doesn't really matter. The change in there is not going to be huge. Like compare 2n to n square on how fast they grow. 2n is almost the same as n compared to n square. So that's why we drop the constants, because they're just constant. They don't really change the growth as much as you think. Another one is dropping the less significant. So again, we're concerned with the worst case. So we know this one is O of n, and we know the nested for loop is n square. So we drop n, because we know n square is gonna grow way faster than n. So at millions and millions and billions and to infinity, this is basically gonna go to 0. Like not to 0, but it's gonna not even contribute as much as n square, right? So that's why n is dropped. It's less significant, and we only stay with O(n) square. Do you guys have any questions for me until this point before I keep moving on? I see some people who seem to be a little bit confused. If you're confused, just unmute and ask me questions. Make sense? Okay. Hopefully it actually makes sense. Okay. Again, the third thing is worst case scenario. That's one thing we always are aiming for when we're doing the big O notation. So something like this here. This is just a function, and inside that function, we're trying to check where of this array am I getting the target element that I have here. And if it is, return true. If not, return false. Again, the target could be the very first thing of the array. It could be the second, could be the third, it could be the fourth, the fifth, the sixth, the seventh, whatever. It could be size at the index size, right? So it could be 100,000, million, whatever. But we're not going to take the easiest case. We're going to take the worst case scenario, which is O of n. And what is n? It's the size, whatever the size is, right? So that's pretty much big O notation. I have somebody in the chat. Okay, I'll show you. But okay, cool. Okay, I'm done with the slides. I want to know if somebody has any questions first here. Any questions? Everything looks good. Seems good. You guys understand what's going on? Okay. So let's go back here. And so how do you access the quiz? You click on files, you click on quizzes right there, and you will find time complexity quiz here. You should have it at the right time exactly set for you. So let me know if you are having any problems with it, and I want you to start the quiz now. And the access code is EE312 password right there. Please look at it here. No space, nothing. EE312 password. Take the quiz. I am gonna So the quiz ends at 4:55, something like that. 4:50 if you start now. So I'm gonna give you a bunch of hints at 4:35. Let's say 4:30, 4:40, 4:40. I'll give you 10 minutes to think, and then I'll give you some hints after that 10 minutes. So 4:40 is when I'm gonna give you some hints. So read through the questions. Question 2 is a little bit hard, and I know you guys didn't do it in class yet. So question 2, I want you to just explain. I don't want you to actually write the proof. Just explain to me, why do you think this is the case? So question 1, you're reading code. You're trying to figure out what's the big O notation. Question 2, you're explaining to me something. It's a proof, but you don't have to write the proof. Just explain to me. Third one is time calculation. You want to see from here which one fits the graph better. So you plug and chug, you plug numbers and see the outputs. This one, you are asked to compare two different algorithms, and you see which one you think is gonna be faster and explain. And then third one is, again, you have a function and you're trying to find what's the big O notation for that function. So the same thing as question 1. So yeah, so the questions are not very difficult, but just take your time, think about it first. What was the password? EE312 password, no space. EE312 password, no space. Okay, so yeah, 10 minutes and we can come back together. So at 4:30, you need to start now though. Read through, and I'm gonna give you 10 minutes to think on your own, and then 4:40 I will try to help. If you have any questions, ask me questions right now, or else start working on the quiz.